Hello, let me briefly show the state of the AR Painter. I will first start in a Maniac Mansion environment, since point-and-click adventures are an interesting example that, in my opinion, has been underexplored. The primary interaction here would be to extract rooms and objects. And so let's say I want to extract this object right here, the doormat. I always forget selecting this, as in now I've just created an image region. And I'll talk about this, more about this pretty soon. But for the moment, let's just say that I want to get this particular image. And then you will see that I just saved that to file. But I can also build up visual inventories like this. And here we, for instance, see all rooms that are in the game. But let's look at the concrete object that we just extracted, which is right here. And so, yeah, it's just the image region as you would expect. But what's now interesting about it is if I only take the door map, the front door, and a key that you will see in a second, then I can actually start solving this game. And so we have three simple components. We have an interaction driver for the clicks and keyboard interactions and so on. We have an item reasoner, so we can have affordances of particular items. And we have a visual perception module, so we can OCR text and we can actually detect objects. So here we see the actual game image, and what I will now just do, I should actually make sure that this stays on top. So let's say always on top, and then I will just let it quickly run through what it does. So through a meta action, it will restart the game, it will select its characters and interrupt the cutscene here. And then those are simple heuristics, so I just tell it to walk to the extreme left 3 times until we see this interesting scene. It will now detect the doormat, look up the affordance, and find that it should pull it back. Here it will now detect the key, will see what to do with the key. Affordance is to pick it up. This is actually OCR, so we OCR from our environment the key, decide to use it with the door. We enter and we walk to the middle of the environment. And so I don't want to get too deep into this, but pretty much we instantiate our perception model with the window ID, get our driver, and then we can tell it to reset the game. Like I said, go 3 times to the maximum left, look for particular objects, like here for the doormat, look up the affordance for a doormat, so it will decide to pick this thing, to pull this thing. We'll find the key, and here we see that it pops up in our environment. So as we OCR this and clean it up a little, we will find that it's key. And here you can see it actually also detected the pipe symbol. Sometimes it does, sometimes it doesn't. This will get cleaned up by this regular expression. And then we can pretty much decide to use this key with the door. So it's not fancy in terms of AI, but it shows how those primitives can be quickly used to script together solutions and to arrive at more complex things too. But let's get back to the AR Painter and look at a couple of more environments. So besides point-and-click adventures, of course, any kind of video game and Atari game environment would work. So here I just launched a Pong environment. And you might know that the first couple of scenes usually, the first couple of frames are usually empty until you, after a few steps, the opponent gets spawned and the ball. And we can now start annotating this scene to make progress. So I click with my color selection tool on the colors, since they are quite expressive here, and you can see that they are added. So here we have the left ball color, the ball color, the left pedal color, the ball color, and the right pedal color. So we can just say that. Call it pedal left, ball, and pedal right. And then we can take the rectangular selection tool and say that we primarily now care about this game area right here. You can have more areas, of course, but for our purposes here, this is the most important one, so let's stick with it. And then we can say that we want to store this, and I can show in a second that this just gets written to a simple JSON file, but I could just as easily push it into Redis or push it directly into an agent. Another interesting thing to note here, though, is that I can also directly now interact as a human with this environment. So here I can play a couple of frames, and it will now automatically select the ball and pedal positions. And so let me quickly jump back and show this. So on the one hand, the scene structure that we have extracted is right here, and the trace of the steps that I've taken is here. And I can then, again, use those in individual AI components. Like here, for instance, I have full traces of the pedal positions, ball position, ball velocity, and previous ball position, a couple of hundred of them. And so I can take a simple machine learning model and train some imitation learning on it. You can do more sophisticated stuff, but this hammers home the point that this is possible. Or similarly, we can take a policy gradient agent, for instance, and just push our information in here. So now we will use the color information and the game area, only focus on that, to extract the pixel-perfect ball and pedal positions and train on that. And then indeed, when I run this, you will see that it starts winning a couple of games, and this will take quite a while, but ultimately converge. Here there's one again, and so on and so forth. Okay, so I think that's probably what I wanted to say about the Atari environments, but let's jump back into the AI Painter, because the thing that is really important to me is more involved embodied agent scenarios. So one thing we can do is quickly launch an MCS environment. And this now launched MCS under the covers. Here it is. And now I can actually see what my agent sees. And I can also, as before, move around the environment and explore it. And by the way, I have more modalities here. So I can also look at the depth map. I can get my segmentation for this. And of course, I can keep walking around. So as we explore this thing, we might find this hidden object, for instance. There's this duck toy behind the sofa. And I can actually ask my agent what it thinks this is. And it will tell me that it sees a duck that is about 3.7 meters away and should be pretty darn heavy because it is made of wood. So that sounds decent. And of course, I can ask it about the other objects. So this is a trophy about 3.5 meters away that should weigh about 1 kilogram. It is made of metal. Or if I ask about this, then it's a sofa. Which, by the way, you might have seen is quite heavy. So it's like 33 kilograms made of fabric. Okay. Another thing I can do is I can now tell the system what I'm interested in. So here in black, I denote the background. And I can also, by the way, make this a bit bigger. So that makes it easier to just very roughly show what I'm not interested in. And then I can also denote the foreground. So here I say this particular area, let's include the trophy, is what I'm interested in. And then I just tell it to segment this. And here you can see that, boom, I have the sofa. This can be used for multiple things. I could now do image-based object detection. I could use this to cut out from my depth map the depth points associated with the sofa and then compute, for instance, a 3D point cloud with that. And we can take a closer look at things like this. So when I actually want to explore the belief state of my agent, I can directly query it and can say, hey, for the run you had at this particular date, at this particular time, at step 32, what was your belief state? And then I actually see, oh, you know, this was the view, this was the depth and segmentation maps, this was what my agent thinks where it was, which direction it thinks it looked into, what kinds of objects it has seen, and also this is the occupancy grid that our so this directly comes from PRAM, the Probabilistic Robotics Architecture for Machine Common Sense. And so we compute the 3D point cloud that we'll see in a second. From that we derive the 3D occupancy grid, project that down into 2 dimensions, and that's a probabilistic representation of which cells around the environment it thinks are occupied. So the greener counts are lower. It has seen those outer walls less as it walked around, but it has seen the sofa and the trophy in front of it a lot. So it's very certain that those cells in front of it are occupied. Another way that you can dive deeper into this belief state is the point cloud. And just for simplicity, I have already preloaded this one. And here I can then start rotating around and translating it and zooming in and out and just analyzing. Here we see the trophy in front of the sofa. And as the agent would walk around, you could complete this map and also look at different steps and so on. So I think largely this concludes the overview of this. Thank you very much for your attention.